Hey, what's up guys, my name is the Cherno. Welcome back to my C++ series. Today we're going to be talking all about maps. If you have been programming for any amount of time really, you probably have heard of a map or a hash map or a hash table or an associative array. Basically these refer to a data structure that allows you to associate some kind of key with a value. So for example, you have some sort of ID, such as like an ID number, and you'd like to use that to look up the rest of the data. At its core, a map is kind of similar to an array, like a vector or a static array even. If you think back to a vector, I've made a video on that by the way, I'll have it linked up there. A vector uses an integer indexing system. Every element that we push into that vector gets an ID, which is its index inside that data structure. That works fine if you just need like ascending indices 0, 1, 2, 3, 4, 5. If that means something to you, then again, that works great. Or if you just need to store like an array of elements and you might care about the order of those elements, but you don't necessarily care about accessing them randomly based on some other value, you just need to have them like in a bucket so that they're stored somewhere and you can iterate through them. That's where a vector is really useful. However, if you need to constantly retrieve specific elements from that vector, that's where it can become a little bit of a problem, because to find a particular element, if you just have one piece of data and you'd like to retrieve the entire element, means that you have to search the entire vector. Sorting can help here, because if you sort it in some way, then maybe you can minimize how much of the vector it has to search, but you still have to search the vector to find what you're looking for. That's basically a problem that maps solve. With a map, you can define a key, which is like the thing that you use to look up your value, and then of course a value, which is the data that you're looking for. If you have that key, which could be like an ID, it could be a name, you can just retrieve the value really easily, because that key can be used as an index, like instead of an integer in a vector, it can be used as an index to retrieve that data. I know we're only scratching the surface, this is going to be a long video, buckle down, but let's dive in and take a look at a simple example to begin with. Now, when we're talking about using maps in C++, there are actually two different types of maps, and we are going to talk about what they are today. We have map and we have unordered map. Why are there two different types of maps? Well, because they're different types of maps. One of them is a sorted map, meaning that all of the elements are actually ordered, and the other map, unordered map, is unordered. So the ordered map, which is just called map, is a self-balancing binary search tree, typically a red-black tree. You don't really need to know the details of that, although we might get into it in a future video, but basically all you need to know is it is a tree, and you typically find elements by comparing them to other elements and seeing like where a key falls as you go through the branches. And because it's a tree, like a binary tree, the elements end up being sorted because they're kind of compared to each other using a less than operator and stored in the appropriate place. That's why when you iterate through an SCD map, you have all of the elements in order, in some order. Now, on the other hand, unordered map is a hash table. It uses a hash function to hash your key, and it can use that kind of generated index to figure out which bucket your value lies in, and then that's how you retrieve your value. This is completely unordered and usually can actually be quite a bit faster than map, but we will get into performance later in this video because it's a bit of a complicated topic. As a basic rule of thumb, I would probably recommend that you use unordered map wherever possible, unless you need an actual sorted data structure, because unordered map usually ends up being faster than map, or at the very least, the same speed. Okay, let's create our fictional scenario example here. Let's say I have some kind of city record that I want to maintain. Now, cities typically have like a name. Maybe they have a population, which can apparently be above 4 billion. They might have some kind of like latitude and longitude. Anyway, you get the point. We have a city. We have data belonging to a city. Now what I want to do is store every single city that we have in the entire world. So I'm going to create a vector to demonstrate this to begin with. We're going to have a vector of city record. These are going to be our cities. And then whenever I want to add a new city here, I can just like, emplace back a city, provide a name. So I live in Melbourne, so let's use Melbourne as an example. Population, like 5 million. Latitude, longitude, I'm regretting even writing that, but let's just write this. I'm going to add a few more cities. We're going to have Loltown, and let's add Berlin, let's add Paris and London, and I'm just going to keep all the rest of the data as is. So now that we have all of this data organized nicely into a data structure, what would I need to do to retrieve information about a specific city? So let's say I want to know the population of Berlin. How would I find that out? Well, with the way that we've currently written this, we'd basically have to iterate through like the entire city's vector and then basically check to see if city.name equals whatever our like the name that we're searching for is, such as Berlin. If it is, then fantastic. We have our city and we can easily look up the population. This will be the population of Berlin. Done, right? And of course we could break from this for loop once we found it, do whatever we want with it. That data is there. Can you see the problem here? There's a few problems. Let's discuss them. First of all, searching every single city that we have is a bit of a pain. Now, it is true that we could maybe order these alphabetically and then use some kind of binary search algorithm to kind of narrow down the city that we're looking for. We know it starts with the letter B, so if we have an ordered vector, then of course, we could optimize that in some way. However, if it is in fact completely random and we have like 1,000 or 10,000 cities or something in here, then worst case scenario, we have just done 10,000 string comparisons looking for Berlin. String comparisons aren't exactly cheap either. So basically what I'm saying is using a vector for this is not really ideal. What I would do instead is use a map. So let's take a look at how we would use just a normal city map. When we create it, it takes in 2 template arguments. Well, actually it can take a lot more than 2, but for the simple case, you have to provide 2. It takes in a key and it takes in a value. Now the key is what you use to index into your data. So again, since we are indexing these by name, we would use an SCD string as the key. So let's type in SCD string. Now the value is the data that we're actually storing for that key, which of course will be a city record. So I'll call this city map. How do we go ahead and put all of these into the map? Well, we basically can use something similar, but I'm going to change it up a little bit into something that's a bit more common. And I'm just going to write city map equals city record like that. And we'll just replace these parentheses with curly brackets. And in here, I specify my key. So let's go ahead and put in Melbourne, Loltown. I don't know how we ended up with Loltown, considering all the other cities are real, but whatever. And that's it. So now we're associating a particular key with that value. In a vector, this would just end up being like 0, 1, 2, 3, blah, blah, blah. But of course here you can see we have an actual meaningful key that is in fact a string, which is the name of the city. So now that we have this data structure, how do I retrieve information about Berlin? Well, the good news is I just do it like that. So let's grab our city record out of here, Berlin data, and that's it. And again, if I want my population, then I can just do Berlin data.population. There's my population. How easy was that? And again, it's not just easy, it's really fast. For a small data set like this, it probably is about the same speed, but the larger your data set is, the faster this will essentially be. This has the added bonus of being ordered. So if I was to iterate through all of these, then these cities would actually be in alphabetical order. But Cherno, you said an unordered map is faster, maybe. How do you use an unordered map? Well, you'll be delighted to know that it's the same, but you just change the type to unordered map. The API is identical. All right, that's pretty much the video. But you know me, I'm going to keep talking for like another 20 minutes probably, so let's just get this over and done with. First, actually, before I commence my monologue, do you need web hosting? You probably do in some capacity, and for that I recommend that you use Hostinger, the sponsor of today's video. Hostinger is an amazing web hosting platform that I personally use for all of my websites and have for quite a while. The best thing about Hostinger is that it's extremely affordable, but it doesn't sacrifice quality. Their servers are really reliable, their user interfaces are fantastic, and they also have a bunch of well-written documentation and tutorials to help you get started. The process of setting up a brand new server is, you're watching it right now, it's really simple. I probably can't even finish this sentence in time. Yeah, there's like nothing more to say. If you need a web host, then just go to Hostinger. That's hostinger.com/Cherno. Just make sure that you use my Cherno coupon code at checkout to get an even bigger discount. Huge thank you to Hostinger, as always, for sponsoring this video. All right, so maps. Let's dive in and take a look at maps in much more detail. Most of what I'm going to explain here applies to both unordered map and map. Obviously, the specific stuff I will mention, but as I mentioned, the API is very similar. So first of all, let's discuss this in a bit more detail. So again, we have a key, obviously an STD string. Now it's really important, first and foremost, that whatever you use as the key is actually hashable if you're using an unordered map, or it has less than operator if you're using an STD map. If we decided that we actually wanted, for example, to be like, well, let's create a map of city record to, I don't know, some additional data that we wanted, maybe that wasn't part of this original struct, such as like, I don't know, the year that it was like founded in or something like that. If we tried to create something like that so that we could pass in a city record and then get information about when the city was founded, as an example, founded map, then if we try to compile this with Control F7, we're going to get a crazy like error message. And I'm telling you, this is one of the worst things about both C++ and maps. If you don't understand what the problem is, you are basically screwed. Like, come on. Like, are we going to read this? We could show you guys how to read this. This is also why, by the way, I always recommend that instead of looking at the error list, which just says, hey man, this std compare thing is attempting to reference a deleted function, whatever that means, you look at the output. Because if you look at the output, then you don't just get that error message that this error list has passed, you actually get all of it, which look how much more detail it has. This is all the one error, by the way. So if you actually follow this through, you'll see that eventually you get to message C reference to class template instantiation. And if we double click on this, it will take us first of all to where we are, which as you can see is that founded map that I tried to create. Really important that you look at the output. Now it's telling you here, by the way, all of the template arguments. So we know that, for example, it's trying to use std hash city record. That doesn't exist. Basically, the reason that we're getting this error is because we're trying to use the hash function to hash city record. We have to hash that key so that we can, store the value and then retrieve the key. Again, everything goes through that hash function, as I mentioned. But city record is a custom type. So how is C++ supposed to know how to hash this? Now, as a side note, if this was, for example, a city record pointer, which again, a lot of people like to use, and if you're coming from a managed language, then basically everything is usually a pointer there. That is a different story. Why? Because a pointer is just an integer. It's a 64-bit integer on a 64-bit, compiled binary. So it's obviously going to be able to hash that because you may as well have written a uint 64t. Right? Easily hashable. The language comes, or the standard template library, I should say, comes with that ability out of the box. Now, city record, on the other hand, without the pointer is no longer an integer. That actually is this data, so it doesn't know how to hash it. So what do? Well, we have to provide a hash function for city record. Now, I'm going to be honest with you guys. This is one of the things that I pretty much Google anytime I have to implement, because I don't remember how to do this off the top of my head. But I have already worked out how to do this for the purpose of this video, so I'll show you how to do it. But yeah, programmers Google stuff all the time, and that's pretty obvious, right? Now, theoretically, if we wanted to, we could kind of reverse engineer this, because we know that it's basically going to come up to here and try and use hash, but it's like, again, going through the standard template library is a bit of a nightmare. So what we basically have to do is create a template specialization for the std hash class that is specialized with the type that is our key. So normally we would implement it like this: namespace std, because this has to be in the std namespace. And then we're going to create a template specialization for the hash struct. Now this hash struct, again, because it's a template specialization, we're going to type in template with an empty template argument, and then we're going to specify the template argument here. So of course, hash of city record is what we'll be creating, and then that comes with an operator, a parentheses operator, which is like the call operator, that returns a size t, which is that hash value, a 64-bit uint, and then we specify a city record, a const reference to a city record, as our key that we'll be hashing, basically. And then it's up to us to return any kind of hash value that we want. Now, we could just return 0, and then obviously all city records are now equal, because whenever you hash a city record, you always get 0. So we don't want to do that. Instead, we want to maybe take a look at the data and be like, what uniquely identifies this? Now, cities don't really have unique names. I mean, there are many cities in the world, especially if you don't just look at capital cities, obviously, but you go further down. So you could hash the name with the population and combine that, and latitude and longitude. Longitude actually probably is a much better way to go. But as an example, let's take a look at name. So how would we hash name? Well, name is a string. So this is obviously something that C++ already has the ability to hash, because std string is part of the standard template library, and the standard template library includes hash functions for most of the types there. So for this, we can just call hash with key.name. Now, unfortunately, it's not as straightforward as that, because hash is a templated class here, so we actually have to put in std string. And additionally, we're actually calling this operator. So with that, so we actually have to basically kind of construct this and then call it. Anyway, syntax looks a bit weird, but this is what we can do. So yeah, looks a bit weird, but does the job. So that is something that you should like copy and paste and store. I mean, whenever I need this, honestly, when I'm working on a project like Hazel, I just look elsewhere in the code base and copy it from there because, again, I don't retain this information. But this is basically how it works. Hopefully it makes sense how it works. You just put in your custom type here. The call operator with that template specialization is what kind of gives you an opportunity to specify how that type should be hashed. And then whatever code you put into this function is what generates a hopefully unique hash for this specific object. Again, your goal here is to be unique because you need to obviously, if it's not unique, then you could type in another city name and it could amount to the same value, which means that it will overwrite data that's stored there. Hopefully that makes sense. Anyway, now if we hit Control F7, then this still doesn't compile because if you read this, no overloaded function takes 4 arguments. So the reason this didn't compile here is because I'm not sure why it just decided to break now, or maybe it never worked, but basically I used in place back with 4 arguments here for the vector, but we don't technically speaking have a constructor that matches that. I was hoping that it wouldn't matter, but anyway, since we're past vectors, if you wanted to make this work, obviously with in place back, you would just write a constructor that took in all of those arguments instead of kind of leaving it up to the struct initializer list, but we are going to just get rid of our vector, Control F7, and there we go, it compiles and everything is wonderful now. So yeah, our founded map obviously works. We can basically grab like a city record such as this and push into that like the year that it was founded, which I have no idea when Melbourne was founded, but let's just say 1850. The interesting thing about this is, again, the only thing that identifies this is the fact that it's a city record of Melbourne. Like this data could be whatever. Like if I wanted to retrieve, you know, the year a bit later, like so, then I could specify whatever I want here. It doesn't matter because it's just going to use this to look up my value because that is obviously what the hash function is using. Now, this is a fantastic time to mention what this index operator actually does because it works a little bit differently than in other languages because this index operator that you use to insert things in will always insert things in. There is no const version of this operator. What am I talking about? Well, let's get rid of this founded map because it's a little bit annoying. If I wanted to look up Berlin, like so, if Berlin didn't actually exist, then this code here actually will insert Berlin into the unordered map and then give me a reference to that newly inserted city record, right? And of course, in this case, we're not specifying like parameters for it. I mean, we're not specifying any values for these variables, so it will just be the default value, which will be like, you know, an empty string and uninitialized memory, whatever. This can be annoying if you are new to C++. Now, I personally use this all the time because if there's a lot of data that needs to be filled out here, and I just want to have access to that city record already in the right place, this is great because I can then go through and do things like Berlin data.name, you know, equals Berlin, right? I can go through and set up everything, and because it's a reference to that already in place memory, I don't need to then later set it. So like an alternative way to do this might be, let's create a brand new city record by writing some code like this, right? Let's set up like the name and the population and like whatever else you need to set up, and then we can just basically get our map and assign that back in, like so. Now the downside here is that you're creating it first here on this kind of stack, and then you're copying that into the map. Whereas over here, apart from not having that final line of code because it's not necessary, you're also avoiding the copy because you're kind of creating it in place and then referencing that memory. So I actually tend to use this quite a lot to just avoid copies and to make the code a little bit cleaner. But if I really truly want to retrieve the data without actually inserting it, then what I should be using is .at. Now, as a quick little note before I show you .at, since this index operator inserts elements if they're not there, if you happen to have like a const map, so if I wrote something like const auto cities equals city map, so now I have a const map, right? This map is now const. If I try to write code like this, of course it won't work because there is no const version of this operator. So if you pass like a const map into a function, you have to use .at. Like I remember back in the day, I was so confused as to why I couldn't use index operators if the map was const. I'm like, but I'm just trying to access, because like in Java and C#, whatever, this is normal, right? But in C++, that operator is kind of like, it has the ability to mutate the actual data, of course, the map, because it can insert elements. So, of course, there can't be a const version. They could have made a const version that would not insert elements, but I guess to keep it less confusing, they made .at instead. So .at is in fact const because it will never insert new elements. It will only return those elements to you. Now, of course, it will return them to you in a const state, which is why that wasn't working. And, well, for this example, it's not going to work because we can't assign to that, obviously, it's const. So yeah, my rule of thumb is I use .at everywhere unless I'm okay with it inserting data, which again, sometimes, like on the fly, you don't mind. If the element's not there, insert it. Sure, that works for me. But a lot of the times, you don't want that to happen. Now, what happens if the data isn't there? So we don't have built-in here. So what's going to happen here? Well, you're going to crash. It's going to like throw an exception or something, or assert. If you use .at, the data has to be there. So how does one check to see if the data is there? That's where we can use .find. And again, it's pretty simple. You can just write cities.find Berlin, which is my key, doesn't equal cities.end. Don't know why my new Visual Studio decides to convert that into that. I guess that's just trendy these days, but anyway, we'll ignore that. And then inside this if block, you can actually use .at because you've checked to make sure that it actually is inside that map. That pretty much covers like a good deal of how to use map, but there is one other crucial part that you might want to do, and that is iterate through the entire data structure. So I want to go through and print every single city. Now, lots of people will tell you not to do this, it's a bad idea, it's a map, you don't iterate through maps, blah, 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 blah. All that is false. Ideally, yes, you wouldn't iterate through maps because a vector keeps all of your elements in contiguous memory, very cache friendly. It's the best thing to do if you want to iterate through elements. That is why vectors in general are by far like the most popular data structure. Most of the time you use a vector because it just stores all your memory in a row and you probably don't need fancy indexing systems like this most of the time. Not saying maps are unpopular, they're extremely popular, but vectors are more popular. However, iterating through maps is not the slowest thing in the world. It is slower than a vector, for sure. If you iterate through a vector, it will always be faster. However, it's also very useful to be able to iterate through a map. And it's also very easy. So all we have to do if we want to iterate through our map here is just write a for loop. Now, I will basically always write a for loop like this. For auto, then reference if you don't want to copy. And then using structured bindings in C++ 17, I can actually just write like the name of my key, such as like the name of the city, and then whatever value I want, so city, right? Because we have a name to city record. Then I just specify my city map. So it's kind of like a ranged-based for loop here. However, we can use structured bindings, which, by the way, as I compile, I realize that we haven't enabled C++ 17. Just go over here. We're on C++ 14 apparently for some reason. Sure, 17 is good enough. You know what? Before we do that, let me just show you what you would do, like in C++ 14. Again, with range-based for loops and everything, what you can do is instead of iterating through it and retrieving the key value immediately, you can just make a variable called like kv for key value, and then you have key value dot first, which is like your, so let's just do auto name is that, and then the city would be your second. So this is your city record. Probably shouldn't use auto to be more clear. And then that is your name. Now you can see that in this case the key is returned as a const value, so we'll have to do that as well because we can't really edit it. So this is like the Stone Age of how you would iterate through a map. You don't really do that these days. Instead, with C++ 17 and above, we can use structured bindings, so you can immediately just have your name and your city over here, and then, well, yeah, you're done. Like this is my name string, and this is my city, and I can access like, whatever data I want. So let's go ahead and actually just print all of the cities. We'll actually run a program for once today. I'll go through, print the name of the city, and then maybe let's print the population, city.population, and that shall be the end of that. stdcn.get. F5, and you can see that I am printing all of my data. Let's kind of, change some of these so that it's not silly. Bring back Berlin. And there you go. You can see that we're able to access, obviously, all of the entries inside our map. Now, you will notice that, of course, they are not in alphabetical order because we are using an unordered map. Now, if you look at this, it does happen to be in the order that they were inserted in, but again, that's definitely not guaranteed. So just be careful with that. An unordered map is unordered. So this would be a perfect time to show you how we would have an ordered map. So Of course, if we would just use an std map instead of that std unordered map. And that's really all we have to do. So now if I hit F5, then you can see that we now have all of these in alphabetical order. How do we remove one of these from the map, you ask? Why, we can simply do citymap.erase and then whatever key we want to erase. So for example, we don't want Paris in here. We just citymap.erase Paris, and that's it, no more Paris. Now finally, the last thing that I have to show you is if we go back to using the founded cities that we had, so founded, or city founded, or whatever it was. So we basically have the city record be the key, and then we have some kind of value. We had to specify a hash function, obviously, for the hash map, for the unordered map, but for the map, for the ordered map, we actually have to specify something as well. Now, it won't complain when you actually just create a new map here, but when you try and use it, so if I try to actually insert a value into here, such as let's just copy this, pop that in like that, Control F7, once we compile it, it will tell us that there is no binary less than operator, right? So again, it's a self-balancing binary tree. It will try and compare the two nodes to each other to see which one is less than the other one so that it can sort it into the appropriate branch. That's not going to happen because there is no less than operator. So how do we define a less than operator? Well, you can actually define one within your custom class itself. So obviously it's going to return bool, and we literally just need to have a less than operator. So const city record other, we'll mark it as const, and then we can return true or false for if it's less than something else. So let's sort these by population. And this is cool as well because you can sort it by whatever you want. Just because it has name, we don't have to sort it by name, although we could sort it by population. So we'll return population less than other population. As a quick side note, this less than operator is responsible for more than just sorting, of course. This is what defines the unique key inside your actual map. So if one city's population is the same as another city's population, they'll actually clash. So it's important that you do this properly, not just for sorting. Let's compile it with Control F7 again. You can see it compiles now. Before we add all of these into this city founded map, another interesting note is because this index operator inserts elements, we can actually write a bunch of statements like this without even setting it equal to the year that it was founded in, right? Because this code itself will actually insert the element in, and that might be all we're trying to do. So that's also something that people do from time to time. Okay, so we're iterating through our city map over here. Let's go ahead and insert all these cities into city founded. So we'll just do city founded and then city, and then, it doesn't really matter when it was founded for this example, we'll just set it to that. And then what I want to do is iterate through city founded, and we should see, of course, that it's sorted by population. So this will be city, this will be founded. The name we can print here. We won't set this. Let's run this program. I'll just comment out this as well so that it's not confusing. So now and again, this is another great example of I just want to insert something, not necessarily set a value, but just insert the key. And finally, if we iterate through all of these, we should see them in ascending order from the lowest population to the highest population, as you can see here. All right, that's pretty much it. Now, what I would like to talk about next is performance between these maps, because performance is very important. I'm a game engine developer. I care about performance. The short answer, as I mentioned, you want to basically use std unordered map whenever you can if you do not care about the order, unless you've actually benchmarked, profiled, all of that stuff, and you can see that std map is actually faster. In some compilers, I have seen that std map is faster than unordered map, and you also have to realize that this very much depends on how much data you have. If you have 200 elements, 500 elements, 1,000 elements inside a map, you're probably not going to see a big performance difference. If you have 1,000,000 elements in your map and you're doing lookups, then the hash map will be much faster if you don't need that data to be ordered. Now, when iterating through maps, which of course isn't the most ideal thing in the world, map generally performs better than unordered map. However, it will be an order of magnitude faster to iterate through a vector. So if you're going to be iterating a lot and not really doing lookups very often, you should still use a vector. But if you're mostly doing lookups, iterating maybe for debugging or every now and then of course you should use a map. preferably an unordered map if you don't need it to be ordered. The long answer is I will probably make a video talking about the performance between these maps and show some actual benchmarks. If you want to see that, leave a comment below. Hope you guys enjoyed this video. If you did, please don't forget to hit the like button. Let me know what you want to see next in the C++ series in the comment section below. And also, if you need web hosting, check out Hosting Up using my link in the description below. Thank you guys for watching. I'll see you next time. Goodbye.